So I'm going to show you what happens when you don't get good data from a data-dependent scan, and you need good fragmentation data because you need a good fragmentation spectrum. So here's a data-dependent scan, and when I pull out all those different scans, if I look at the MS1, I got a beautiful 304 peak there, and the data-dependent scan saw that peak and did the MSMS, and this is great. So what we see here is we have a little bit of 304, but we have a lot of fragment, that 182 fragment. You have to have fragmentation in an MSMS spectrum for the data to be meaningful. Here you can see the 304 fragmented to the 182. Okay, while we're here, let's look at this shorthand here. This shorthand up top shows, oh, this is an electrospray ESI. This is MS2 as an MSMS. We isolated the 304 and used collision energy 35. That's where the mouse was right there. Okay, this is the MS1. Now this says ESI full MS, so we're not doing MSMS. We're looking from 50 to 500. So you can look at that title and see what it did. See here again, it did MS2 of the 304 with collision energy of 35. Okay, let's look at this guy. This is the MS1. It's 251. Okay, now data dependent scan also took an MSMS of this. But when we look at this, when we click on this MSMS, we can see that it did isolate the 251 ion and used collision energy 35, but all we have is what's called the parent. All we have is the 251. We don't have a fragment. So we can't get meaningful fragmentation data from this, and we need to fix this. Right now we have the MS1 spectrum that gives us the protonated molecule at 251 and tells us that this is probably something that has a nominal mass of 250. That's definitely not enough to get us an identification. So then we say, oh, let's look and see how it fragmented in the MSMS, but we have no fragmentation. The MSMS just shows us the peak at 251, and that tells us the same thing that the MS1 told us, that we have a protonated molecule at 251, and this thing probably has a mass of 250. So I'm going to show you how to manually go in when the data-dependent scan picks collision energy 35, but you don't get any fragments. I'm going to show you how to make a method where you manually go in and you increase the collision energy to try and force that parent ion to fragment. So we want to try and force that 251 to fragment and get a fragmentation MSMS spectrum. So let's return to the roadmap view in Excalibur, where we can go into instrument setup and make a new method. I'll just go ahead and open up that default method. Okay, so here we have the mass spectrometry settings, and just like we did with the data dependent, we're going to add a scan event. So it's going to do MS1 and scan event 1. Now before I do anything else, I'm going to go ahead and save as so I don't mess myself up. And I'm going to make up a name for this guy. And I'm going to go ahead and set this up to fragment both that 304 ion that we observed in the MS1, and even though it fragmented fine with data dependent, I'll do that just for kicks. And then we'll do the 251, which did not fragment in the data dependent. Now importantly, when you set this up manually, you have to know what you're looking for. In this case, based on my previous data, I know that I'm looking for the 251, and I'm going to go ahead and do the 304 as well. So scan event 1 is going to be the MS. Scan event 2, I'm going to set it manually here with that radio button to be an MSMS scan. I'm going to look for 304. I don't need to go all the way up to 500 because the biggest peak in here should be 304. Okay. I'm going to tell it, importantly, in this window, I'm going to tell it, I want you to find 304. Isolate 304 with an isolation width of 1. So it's really 303.5 to 304.5. And then I get to set the energy. This is the important part. With the 251 previously, I was not seeing good fragmentation, so I'm going to need to set the energy higher. But I can do several different scans across that peak and still get good data. I'm going to set it a little bit higher here. It was at 35 before. I'm going to set it at 50. I'm going to add another scan event. Well, first let me fix that. That looks good. I need to fix my mass range here. We don't need to go all the way from 80 to 2000. We don't even need to go from 50 to 500 because there should be nothing bigger than 304. You shouldn't fragment something and get a larger ion. So I'm going to fix this guy to be maybe 80 to 325 or 80 to 350 or something like that. If you try and go below 80, it will yell at you here. I'm going to punch in 50. And when I punch enter here, 50 to 325, it's going to say I can't go below 80. For MSMS, it has trouble going below 80, so I'm just going to say 80 to 325 is fine. So I'm scanning from 80 to 325 to look for fragments. I've set it for MSMS, isolate the 304, and use collision energy of 50. Okay. So I have MSMS of the 304 at collision energy 50. Now I'm going to do another scan event just in case 50 isn't enough. I might as well get one good MSMS spectrum out of this run. So I'll look for the same ion. I'll set it from 80 to 325. I'll say isolate the 304, isolation width of 1, and I'm gonna crank this energy up. That might be a little bit aggressive, but I'm gonna go to an even higher energy. So scan event 2 and scan event 3, I'm trying to get fragmentation spectrum off that 304. Okay, but I also had that 251 in there, so I made yet another scan event 4. And for this one, I'm also going to say I want MSMS, but this time I'm going to target the 251. I don't need to go much higher than 251. I shouldn't see anything greater than 251 at fragments, so I say 80 to 275. Now I'm going to tell it, isolate the 251. 35 did not work for us previously, so I'm going to say try 50. Go a little bit higher, a little bit more energy to fragment that thing. Just to be safe, because I want to get it all done with one run, I'm going to make another scan event where I'm also going to target, I'm going to do the MSMS of that 251, and I'm going to go even beyond 50. So I only need to scan 80 to 2, nothing much bigger than 251. So I'm going to isolate the 251, and I'm going to set a pretty high energy. So between scan event 4 and scan event 5, one of those should probably work. I should probably actually fragment that 251 and finally get a fragmentation spectrum. Now remember, apples to apples. When you find a condition that gives you a good fragmentation spectrum for that 251, you have to run the standard under the same conditions. In other words, if I do MS1 under certain conditions, and then I found that to do MSMS, I needed an energy of 50, then I need to also run my standard under the same MS conditions, and I need the standard with the MSMS collision energy of 50. So you have to do apples to apples. And the nice thing is, by programming multiple scan events, you can try several different MSMS conditions in one run. So you don't have to run the same sample a bunch of times trying different energies. You can try out different energies and in the same run with these scan events. You also see, if you have two different things in your run, you can try out both things in that one run.